So today I will be talking about the intoDBP project. This is a project that's focused on disinfectant byproducts, which are formed as the consequence of the reaction between natural organic matter, which you get in the catchment, and disinfectants such as chlorine. And there's a whole range of disinfectant byproducts that are formed that depend on the type of organic matter in your catchment and on the type of disinfectants that you are using. But we in Ireland focus on trihalomethanes, THMs, which is the most commonly reported disinfectant byproduct. So really, in terms of disinfectant byproducts, what we know in terms of what they are and how we measure them is really the tip of the iceberg. But it is a recognised health issue. It's associated with a lot of health issues, including associations with cancer rates. Because of that, the EU Drinking Water Directive asserts that member states need to take action to try and reduce the amount of disinfectant byproducts in their drinking water. But they recognise that you can only do that if you don't compromise disinfection itself, which is so important for reducing microbial risk in our drinking water. So water managers are faced with this balancing act between dealing with the chronic illness or acute illness that microbial infection will bring, and then this more long-term health issue associated with disinfectant byproducts. So because of that, the intoDBP project, which is an EU project, is focused on trying to deal with these issues. And it has 13 partners in Europe, all dealing with different aspects. So there's aspects dealing with sensor and monitoring technology to improve detection, looking at distribution networks and trying to improve monitoring of disinfectant byproducts within the treatment network itself, improving treatment technologies, and then looking at health exposure. But the part that Ireland or Dublin City University have for this project is focusing on the source water. So our whole focus is on source. So in other words, our focus is on the organic matter, the precursor to disinfectant byproducts. And the project itself has a number of case studies across Europe linked to countries that have high levels of disinfectant byproducts. So we have Cyprus, Spain, and Ireland involved in this. But Ireland is unique in that our case study site is focused on, rather than on these larger municipal plants that service large cities, Ireland is focusing its case study sites on group water schemes. And specifically, this project is focusing on 3 group water schemes that are clustered in County Mayo. And of course, for Ireland, it's really important because in 2015, the European Commission started infringement proceedings against Ireland for their failure to comply with THN standards in drinking water. And it's still an ongoing issue here in Ireland. So what are we doing here as part of in DCU to address this issue and focusing on the source? Well, we have 2 specific objectives that we're trying to meet. The first is to review potential mitigation measures for reducing dissolved organic matter, the precursor to disinfectant byproducts at source. And the second is then to develop modelling workflow that will help to simulate short-term and long-term forecasting of organic matter in the catchment, which should help water managers better manage their treatment plant in terms of what's incoming into the plant with regard to organic matter, and then how best to react to that. So since our focus is on organic matter, I'm just going to give you a little bit of a brief overview of what organic matter is, what is it we're talking about, and why is it such an issue. So organic matter is basically anything organic. It's plant material, soil material, the byproduct of bacteria and algae production. So it's coming either from the catchment, from the terrestrial environment, in other words, leaf litter or soil, or it's coming from internal production within the system. This is what we call autochthonous carbon, from algal production in a lake, as an example. And you'll often hear the terminology dissolved organic matter, or dissolved organic carbon, or total organic carbon, which is another way we have of measuring it. And these terms, although measuring something slightly different, are often used interchangeably. And in fact, colour is also another measure of dissolved organic matter, because dissolved organic matter is in its very nature coloured. And there's various types of dissolved organic matter depending on its source. So you can have organic matter that's more humic-like or fulvic-like or protein-like. And the type of organic matter determines the way in which it reacts with chlorine in the treatment plant. So where does this organic matter come from, and what are the aspects within your catchment that's important? Well, since it's coming from soil and from leaf litter, really land cover, soil, catchment, and hydrology and geology are all going to impact the organic matter that you get in your treatment plant. But then there's processes at play that impact microbial breakdown specifically, that actually interact with that normal background land cover aspects that actually increase or decrease the amount of dissolved organic carbon that's actually released into a catchment. So things like temperature, soil moisture, and rainfall are all going to impact those microbial processes. And then, of course, within a lake itself, it's the algal production. So it's phytoplankton blooms that are going to produce organic matter within a lake itself. So dissolved organic matter concentrations at the point of water abstraction are going to represent the sum of all of these processes that are at play. And it's going to impact not only the quantity, but also the quality or the type of organic matter that we're dealing with. But that's natural organic matter, and it is something that's natural. But there is lots of activities within the catchment, human activities, that also impact or drive organic matter production. So things like urban runoff, drainage of wetlands, agricultural activities such as manure spreading, land management activities such as forestry or clear felling, peatland drainage, industrial discharge. All of these activities within our catchments are going to impact the release of that natural organic matter in the background. And then what we know is that in recent years, in the last couple of decades, there has been a global increase in the export of organic matter into our waterways. Now, why this is happening isn't fully explained, but what we do know is that it is related to precipitation, because precipitation promotes dissolved organic export to surface waters. High precipitation, high temperatures are going to enhance microbial breakdown, and there's going to be faster flushing rates of that dissolved organic carbon into surface water. And then also the accumulation of dissolved organic carbon because of drought events, that was already mentioned today. More drought events, the more microbial activity that can actually take place to break down the dissolved organic carbon. And then if you follow that by a heavy rainfall event, you're going to get more flushing. And then finally, our longer growing season, the increased temperatures increase the occurrence of algal blooms in our lakes, and that's also going to increase dissolved organic carbon production. So given that we know that there is human activities that impact dissolved organic carbon, things that you do in the catchment, these are direct impacts, but also indirect impacts of climate change, then there should be ways in which we can mitigate or manage the production of dissolved organic matter in our catchments. And that's where the focus of this project is at. So what we are trying to do is determine, is there source water protection measures that we can use that can actually reduce organic matter carbon production? What we found is that there's actually very few studies that have actually gone out and directly examined source protection measures for organic matter reduction. What you tend to find is that source protection measures focus on other parameters, things like nitrogen or phosphorus or pesticides, herbicides or microbes. But there's very few direct actions that have focused on where we're introducing this measure to reduce organic matter specifically. So there's a gap of knowledge in the literature in this regard. So to try and fill that gap, what we are doing is we are examining the types of source protection measures that are already in use and identifying those that are likely to have potential for organic matter reduction. There's even activities within the catchment mitigation measures that are to do with reducing, for example, or increasing carbon sequestration, that are to do with our carbon targets rather than directly to do with source water protection measures, but still have an impact on, or potential impact on, organic matter for drinking water production. So example is restoration of our peatlands. So re-wetting of our peatlands has the potential to reduce organic matter outflow to our treatment plants. So that's an example of something that's used for something else but has potential. Again, there's other on agricultural land. Buffer strips is another example. Yes, often applied to reduce nitrogen and phosphorus runoff, but also still have the potential to reduce organic matter production. So what we're doing is we're trying to collate all of these various land use factors that could lead to dissolved organic matter production, the activities on those types of land that actually lead to that production, and then looking at the various source protection measures that have potential to reduce organic matter. And what we really need to do to build on this is then examine, we've been carrying out stakeholder forums and interviews to try and examine on the ground how effective these measures are, how likely people are to buy into them as a way of reducing organic matter, and what the view is from water managers with regards source protection for organic matter reduction, rather than the focus just at the treatment end. And there is a survey that we have to try and help us with that, which is out in the foyer. And there's a link as well, a QR code. You can do it on your phone. So we'd be really appreciative if we could get your feedback for that regard. And then the second aspect of our project, the other big component that we have, is our modelling component for this project. So what we're aiming to do is, again, focusing on source, focusing on organic matter at source, is finding a way of better modelling that dissolved organic carbon within the catchment, within the source water. And if we can do that, what we aim to do is to provide a tool that allows decisions to be made at water treatment plants. So if we can predict what's going to happen in your catchment with regards to dissolved organic carbon, either in the short term, perhaps weeks or months next season, or the long term, out way into the future regarding climate change, we can help make better decisions regarding the need for types of treatment or treatment adjustment within the treatment plant. That's just better informs decision making. So to do this, we need to build these models, that effectively mimic or predict for us what measures, oh thank you, I'm sure you know, what predict those measures better, the concentrations better in the catchment. So we can do this at different scales. It can be done at the catchment scale, so looking at rivers. It can be done at the lake and reservoir scale. But what we're trying to do is we're trying to link both. We're trying to link the catchment scale to the lake and combine that. So eventually then, hopefully, we'll be able to link that then even further to the treatment and to the distribution system beyond the treatment plant as well. And there's two ways we can do this. We can focus either on what's called process-based models. And they're models that really investigate the processes that are at play, all those biological processes, microbial breakdown, and things like soil moisture, etc. The actual processes that are occurring that actually produce organic matter in the catchment. So we build models that incorporate all those aspects and use that then to predict the behaviour of dissolved organic carbon. And we've actually done that already here in Ireland. Now the test bed for this has been the Lough Fia catchment in County Mayo. It's in the Burrishoole catchment. Lough Fia itself is not a source water. It's not used for drinking water. However, the Marine Institute house and operate instrumented buoys that collect huge amounts of data. And that has been really, really beneficial to us because it generates the type of data that we need to run these models. So we have developed the models at Lough Fia, and this is an example of a process-based model. The red line is the model, modelled concentration of dissolved organic carbon, and the black line is real observed values of dissolved organic carbon. And you can see that they align very closely together. So this is a model that's working very well based on this process design, understanding the kind of processes that are play in that peatland catchment. And then we also have the empirical approach, and this is basically based off these mathematical relationships. So there's not really an understanding of the processes at play here, rather it is a numerical relationship between one parameter and another. And the way in which we do this is using machine learning. And machine learning is brilliant for using these large computational, it can run these relationships again and again and provide us with the best output of the most likely, the best relationship. So huge amounts of data. But we have applied it again in Lochfia to begin with. And what we've done is taken a whole load of data parameters, things from meteorology like temperature, air temperature, precipitation, etc., measurements from the soil like soil moisture, soil temperature, and hydrological, so water flow, etc. And we've put all those parameters into the model and allowed it to develop these relationships between things that we might otherwise not notice. And the model here, the model is the black, and the blue is the data we use to calibrate it, but the red is the validation data. And you can see that there is, again, a very good match. So we were getting this model to work very well for Lochfia, the lake. So the process-based model was working for the rivers flowing into the lake, and this model allowed us to model what was going on in the lake. And then the model even took one step further, and we could then ask it to give us back the variables that were driving the model, had the most effect on the model. So in this graph, anything past this red line here down the middle is a variable that has really got a strong underlying effect on the results we're getting from the model. And what it turned out is that it was producing information like soil temperature was important, soil moisture was important, the inflow of DOC from the catchment, which we had modelled using the process-based model, was working very well. So we redid the model just using those important variables, and this is the rerun model, and you can see that it's almost working as effectively as the model that used that huge amount of data. And why is this important? It's important because it's allowing for scalability. Essentially what we're intending to do is to produce something that is usable without all of this data that Lochfia has, just in anybody else's catchment, just using data that we can get from Met stations. So Met Éireann data, etc. So making it applicable and usable and scalable across multiple catchments, and not relying on this large amounts of data to help drive the model. And then the next step to this is then using that model to forecast into the future. The first step will be to do that on a seasonal scale, so what's going to happen in the next few months, and it's what we're working on now. But we've already started the process of doing this for the long term, what's going to happen into different climate change scenarios. So if we meet our climate targets, if we don't meet our climate targets, what's the likely outcome by the end of the century? And we've already done this for Lochfia, so we can predict under 3 climate change scenarios what the DOC concentrations are likely to be in Lochfia. And the different coloured lines here indicate that, red, yellow, green. So red is the worst case scenario, green is if we start meeting our climate targets. This is really useful, or should be useful, because it can allow people to plan into the future. There might be schemes that don't have an issue with THMs at the moment, but depending on how things change because of climate change, there might be an issue into the future. And this will allow us to within a range of possibilities, predict where is the areas that are most likely to be an issue into the future. So in summary, this project, what we have been aiming to do is to approach the issue of disinfectant byproducts from a multi-barrier approach, to not just take it from the treatment plant point of view, but to see what can be done within the catchment to better manage and mitigate the precursor to disinfectant byproducts, which is organic matter. We have found that there is potential for source water protection for this, but in reality, there has been very little work, experimental data-driven work, that has shown the effectiveness. And there's also, I think, a lack of understanding that we're coming up against with regards how it is possible to also help deal with disinfectant byproducts at source and not just focus always on the treatment plant as the solution to the problem. And then finally, the modelling that's ongoing at the moment is showing real potential for allowing a tool for water managers to make better decisions. So that if there is high levels of organic matter coming into their catchment, and you can predict that into the next season, you'll be better able to make decisions about what you need to do in your treatment plant to better and more effectively manage that. So that's it, and thank you very much. I'm just highlighting the QR code for the survey.